Thanks for joining us for today's session, Building a Sustainable Urban Terrain. We are honoured to be part of the Singapore Geospatial Festival. Thanks to SLA and GeoWorks for inviting us to be part of this fantastic event. Technology has evolved beyond 2D maps and apps into the 3D space, bringing a new perspective to data visualization. In today's session, we will be exploring how 3D capabilities complement 2D data visualization to deliver a comprehensive understanding of the real world to support public sector decision-making around the built environment and transport. And I'd like to welcome the person who will be leading the discussion today, Sharon Jin, Senior Manager for Product Technology from Esri Singapore. As a Senior Manager within Esri Singapore, Sharon leads a passionate team committed to working with clients to uncover new ways of working with geospatial technology. Sharon has worked across many sectors and has a particular interest in the utility and built environment industry, where she has seen growing interest in BIM, 3D and digital twins, and is excited to help organisations uncover greater potential from it. Welcome, Sharon. Take it away.
Thank you, Laura, and thanks to many of you who have joined us today. I'm sure many of you are very familiar with maps and you use it on a day-to-day basis. You use it to get around from place to place. You use it to see what's the nearest restaurant around where you're at right now. And we also see it widely used in many of our users in the various industries like built environment, public sector, utilities and transportation, and also even defense and homeland security. And some of these examples are what you see on the screen here today. You use maps for your land planning workflows and management of your land boundaries, and also associate the properties of the land areas with it, like the land use type and the plot ratios. You have a map to look at where all your trees are located. What species are they? When were these trees planted? And what's the current height and the size of the tree right now? And another example that you see on the bottom left, that's a map of all your transport infrastructure and all your roads. And they show you how we connect from place to place and where the locations of MRT stations, bus stops, and how their routes are being maintained. And similarly, other linear assets like water pipes, telco lines, and your electrical cables, they are more easily designed and maintained on the map rather than in plain tables. We have also used these maps very extensively in analyzing trends and patterns in our data. We generate density maps like what you see on the top left. This is the density map of showing where there are higher numbers of HDB sales. And we also look at aggregating statistics that we are monitoring. For instance, on the top right, those would show the price of the resale price of HDB over boundaries in Singapore. We're also able to assess the demographic profile of a location within 10-minute walking distance of it. And this looks at the feasibility of using that location to open up a retail store. And we can also look at travel patterns of consumers to specific stores within the service coverage of a location. And this helps retail stores identify certain stores that somehow do not attract customers within their service areas. And while we continue to gain a lot of insight from the data that we illustrate in these 2D maps, the evolution of technology is moving so fast. And to answer new questions, we can add dimension to our data. Some of these questions can be related to your land use type. How does this affect how a building is designed? How does plot ratio affect how many floors I can build within that land parcel? Will this planned building affect the landscape of the urban design in my area? Or how will new buildings and its shadows impact the buildings around it and the vegetation? Or you might ask, if I look at a map of trees, how much shade do these trees provide? How much does these trees contribute to the green spaces that we have in our neighborhood and contribute towards fulfilling the Singapore Green Plan? How will my landscape look like if I had different species of trees with their varying heights? Or how do I even plan where should I be planting trees or infrastructure so that I maintain connectivity between green spaces and encourage more wildlife? How far away are we from our sustainability goals? And if you look at the image on the right, you see a very congested map of many different pipes. They appear to conflict with each other, cut across each other, but are they really intersecting and conflicting with each other? Is there space to actually run new pipes in this very congested looking area? So what we have seen very commonly in how 3D GIS can make a huge difference to the insights and the understanding that you can get from your data. We all live and experience the world in 3D. And in Singapore, most of our utilities run underground. So being able to see through the ground is sometimes very important. Knowing how deep the pipelines are, where they are, will make a huge difference to utility companies when they do maintenance works. Knowing where electrical cables are and not digging into them can make a difference between life and death. And if you look at the picture on the top right, this is a 3D representation of that very congested pipe 2D map that you saw earlier. Now, when you look at it in 3D, you can see that the height or the depth actually makes a huge difference in differentiating the space that the pipe takes up. So what appears to be a lack of space in 2D may not be the case if you look at it in 3D. Being able to visualize which units within the building consumes more electricity than others, like what you see on the top left here. This helps inform which tenants would require more education in energy conservation. Being able to visualize different heights of buildings based on their footprint helps designers to look at different scenarios and generate different views and designs and conceptual designs to see what's possible and how it impacts the surrounding. And with our sustainability efforts now pushing towards clean and green energy, the solar potential of buildings can also be analyzed using 3D models as what you see in the image in the middle here. And in the design stage of a new building, you may also want to analyze how a planned building can impact the visibility from a specific location within an existing one. As what you can see in this video, when I pull different lines of sight from a specific point on the building to various locations, you'll be able to see which areas are actually blocked by that new building in orange. Now, if I extend the line of sight analysis a bit more, we can look at visibility being analyzed as a view shed. And this actually better represents how we view the world. And what you see down here is that you'll be able to see how a view can be blocked by a new building that is going to be constructed as the person moves along that road or at different points along this road. When I have realistic 3D models of my different plant species, I'm able to put that in a 3D landscape like what you see here and be able to look at the shadows that the trees will cast on its surroundings, and that approximates the shade that the tree would give. And I'm able to look at it at a different time of the day, at a different time of the year. Being able to run your operations in 3D can also help you identify patterns of specific faults that may occur more frequently on a certain stack, or certain units that may have certain faults that can impact another unit. For instance, you may have faults reported on leaks within a certain unit and faults that are mildew issues of a unit. You're able to correlate these two issues and look at whether the frequent leaks in a unit may have caused mildew issues in a unit directly below it. We provide people with the technology so that the data serves them and helps them to gain additional insight and understanding. Now, you might say that, wow, the technology is great, but I only have 2D data. How should I actually go about, looking at things in 3D? So I'll be sharing some very quick ways that you can extend your data into the 3D space just by using this out-of-the-box tools in ArcGIS. So you can start off with a very simple 2D map of your building footprints. And just using the 3D extrusion tool, you can transform your 2D buildings into 2D footprints into 3D buildings and set that height to an attribute value, which you already probably keep in your data. You can define that shape of the building by setting different configurations of the outlines, and there are various options that you can use. I'm also able to visualize individual floors within a building from my 2D floor plans. And I do that by assigning a different color to each floor based on the value that I keep in my data. And you can specify that height based off an attribute that is actually stored in your data as well. And if you maintain energy consumption figures associated with each floor plan of the unit, you're also able to visualize and use the tools in ArcGIS to visualize where there are actually higher consumptions. So here I select the energy consumption, and then I use that to color my map differently based on the amount of energy consumption from each unit. And similarly, I can specify the height of each floor, taking it from my data as well. Or you may have already a 2D floor plan, a 2D CAD drawing of your building. You can start off by importing this CAD into GIS and georeferencing it in the correct location. You put the floor plan at the correct height for your floor. And to make it more realistic, you can extrude it into a 3D map by building the walls around the 2D edges. You may also have BIM models of your building that you can easily import into ArcGIS. Here you can see both the CAD and the BIM represented together in a single screen. If you have 3D scans of your interiors of your office, you can also mesh that up together with your BIM and visualize it in a single scene. And here you see a cross-sectional view of your indoor scan, and you can just drag the handles of this cross-sectional plane to look through this indoor scan and look at what's inside your building. You're able to change the rotation of that plane and look at different views of your cross-section as well. You are also able to walk through the indoor scan for different locations within your building. And this can be very useful for visual checks. And using the measurement tool on the scene viewer, you can measure the length and the height of various assets that are captured within these indoor scans. So what I've just shown earlier is a very few quick and easy ways of enhancing your data with that 3D perspective. And we can already see that added dimension, giving you more understanding into your data and gaining more insight from there. So I'll be showing you some other ways that our users have made use of various technologies to complement and enhance their 3D experience. Our users have created photorealistic digital twin of the city using reality capture technologies and processing them into 3D meshes. This provides that ideal canvas on which you can overlay your critical assets, the locations of them, and the information that's tied to each of these assets. We can also visualize statistics such as water consumption figures draped over this reality capture, giving better indication of trends and patterns of your water utilization. Now, if we take reality capture to the next step, we can also use it in monitoring the progress of a construction project. So what you can see here is a use case where I use drone imagery to capture at regular intervals within a construction duration. This provides me with a realistic and visual reporting of my construction status. When I view that against the BIM, and I'm able to filter by the various floors within my BIM model, I'm able to look at the accuracy of my construction against the plan design. I'm also able to take measurements of the actual construction site to ensure that my actual building is in line with what I have planned. Now, extending the use of BIM as a collaboration tool during my planning and my design of my infrastructure, users are also able to leverage on ArcGIS and the Autodesk Construction Cloud, this integration between the two, to visualize both the geospatial on one side and the BIM components on the other side. They are linked by the various disciplines within my BIM file, and the information is accessible from both the GIS space and the BIM space. I'm able to visualize how a new planned building, how it would look like against my existing landscape, and to possibly identify conflicts between the two. And then I can update and mark it out on the BIM space to inform the designers that there are potential conflicts here. And as game engines gain popularity as a medium to provide rare aesthetically pleasing user experiences, we have our ArcGIS Maps SDK that provides an avenue where your data in ArcGIS is fed in and rendered using the features and the functions available in game engines like Unity and Unreal. This eventual app that is being created relies on the live link to your data that's published on ArcGIS, where it's easy to manage and maintain your geospatial data. And our users have also asked us how we can take the 3D experience to a more immersive level. We already view our 3D information on a web browser through the use of web scenes, and we control our viewpoints using the mouse. That's not the most natural way, as humans experience 3D. So we all know that using VR, using a VR headset, we're able to be a bit more natural in terms of controlling how we view the world in 3D. And this is what you see over here, where we can generate various viewpoints, and this scene can be viewed from a VR headset and visualized in an immersive level. And ArcGIS provides the tool to easily generate this scene that can be loaded on your VR headset for this immersive experience. Gaining the understanding of connectivity is also very powerful when we extend what we have achieved in 3D and bring that indoors. And ArcGIS take indoor wayfinding a step further by catering to different types of floor transitions with an option to generate a new route that takes accessibility into consideration. And that's why you can see in many earlier examples where a shift of 2D to 3D has added a layer of insight in how we plan and operate. When we visualize that route in 3D, this gives you a better sense of spatial awareness while navigating in your destination, improving the whole wayfinding experience in general. We are also able to cater for emergency situations where we can indicate parts of the routes that are inaccessible within a building, and the system will be able to auto route you by a new route to bring you safely out of the building. And this capability is powered by ArcGIS Indoors, which provides you the tools to convert from CAD and BIM floor plans into floor-aware indoor maps. And we are also able to auto-generate these indoor wayfinding routes from these floor plans. So it not only enhances the indoor wayfinding experience, it opens up the possibility of easy tagging of your indoor assets or incidents within the building to its floor level. It also comes along with space planning and reservation functionalities. Now, if you'd like to continue the discussion on ArcGIS Indoors or other topics that we covered today, you can scan the QR code here to leave your contact details or register your interest for an upcoming session to test drive ArcGIS Indoors. Back to you, Laura.
Thanks, Sharon. Just before we start the Q&A, I did want to mention that today's session has been recorded and we will be sending that directly to your email, and it'll also be available online in the coming weeks. As Sharon mentioned, if you would like to continue the discussion on ArcGIS on Indoors or other topics we've covered today, please scan the QR code and you can leave your contact details and register your interest for an upcoming session. We'd also like to invite you to join us in the next session happening tomorrow at GeoWorks. We're joined by Channel 8 News, who are sharing how they've gained new insights into current affairs programming using spatial analytics. So that will be fantastic and great to see everybody in person. But with that, I'd like to open up the Q&A session. And just as a reminder, if you haven't had a chance to type in your question because you've been watching Sharon, you can do so through the question box, which is in the GoToWebinar panel. But Sharon, we have had a couple of questions come through already. We have one from John asking, what BIM and CAD formats are compatible with ArcGIS?
Yeah, so there are many different formats that are actually supported natively in ArcGIS. Within the ArcGIS Pro desktop application, we can bring in Revit and IFC natively, which means to say if you have a Revit file, you can directly drag and drop that into the map and you'll be able to visualize that. For CAD formats, we can bring in DGN and DWG directly into ArcGIS too. So there are other formats of CAD that are also supported through our data interoperability extension. So that opens up not just various formats in BIM and CAD, there are also a lot of other GIS formats or non-GIS formats that can be brought into ArcGIS through this extension.
Okay, great. Another question here asking, this is around reality capture, asks what solutions does Esri have to support reality capture use cases?
So we have a huge suite of Esri products for those of you who may be very familiar. And as part of that suite, we have SiteScan, which is a product, a software that helps you to be able to plan drone flights. And that supports your reality capture process. So it has this very easy to use mobile application that you can use to plan and fly your drone, as well as software as a service type of application that you can use for your imagery processing after capturing, the images from your drone flights.
Okay, great. A couple more questions have come through. How do we better visualize 3D underground utilities data sets? Do you have any tips there, Sharon?
Yeah, this is a very common question that we get from our utilities customer. There are various considerations that you need to look at when you want to try to answer this question. So assuming that you have all the data that you need, for 3D underground utilities, you have the depth information of your cables and your water pipes, you have the diameter or the size of that pipe, you would be able to use ArcGIS Pro symbology to represent the pipes with the correct depth underground. And using the diameter, you can represent the size of the pipe realistically as a symbology as well. Right. Of course, if you want to go a step further, you can add on textures to your pipes. You can, for your point features, you can make use of CD engine symbology to give a realistic 3D symbology for your various point assets like your water hydrants, like your manholes, right? So there's a lot of possibilities that that are within ArcGIS Pro that you can use to represent data in 3D. Yeah.
Okay, great. Another one here, still around the underground utilities in 3D. What data and attributes are required to view underground utilities in 3D?
Yeah, so like I mentioned in the earlier question, you will need the depth information of the various vertices within your pipes. So at every single point where you actually, when you draw your pipeline, you drop a point within that pipeline graphic layer feature, you will need the depth information. And that, within ArcGIS Pro, it would automatically be able to visualize the correct depth, right? So that's one very important piece that you will need. To make it a little bit more realistic, you need that diameter to give the different size of the pipes. If you have BIM models, of your underground utilities, you can also easily bring that into ArcGIS Pro and represent that actual BIM within, the underground space that it takes up from the beam itself.
Okay, great. Next question here. How do we import 3D models into ArcGIS Pro?
Yeah, there are various techniques that we use to import 3D models, and it also depends on, what is that 3D model, what format is it. So like, for Revit and IFC, we can bring them in natively. We generally convert them into a ArcGIS feature before we actually publish that out for the web, right? So other 3D models like Collada, like OBJ files, or even CDGML, right? We can make use of data interoperability extension to bring them into ArcGIS formats before we view them in ArcGIS Pro. And we can also use the symbology function within Pro to bring in your 3D object models as well. So it really depends on what format that is, and we can definitely take that conversation further. You can scan the QR code, leave your contact details, and we can reach out to you to continue the discussion.
Thanks, Sharon. So we have come to the end of the questions, and thank you, everybody. Great questions for today's session. If you please do reach out if you, as Sharon mentioned, if you do have any other questions, and if you're at GeoWorks tomorrow, please do come and say hello to the team, and we will ask you. You can come and ask us any questions as well. But again, thank you, Sharon, for today's presentation, and thank you to everybody for joining us today.
Thank you.